Test. There we go. Stupid update. Messed up my mic, apparently. Good morning. Or I suppose good afternoon. So here is the plan for today. And for the next bit of work, really. Took a few days off. I'm hoping I'm substantially refreshed by this. We will see today, based on how work goes. If so, then I know what the next block of work is, and I know what needs to be done next for RL to advance. If not, then I will take care of some administrative stuff this week, catch up on a bunch of meetings, on business stuff. We'll try the hard research block next week. But we shall see. But regardless, the thing that needs to happen with Puffer now is hyperparam sweeps need to be way faster than they are. There's a lot of overhead. They need to be able to cleanly account for two different costs, being steps and wall clock time, in a way that's clean and makes sense. This needs to be automatic, and this needs to be robust and let us sweep over a bunch of parameters that we haven't been previously using. The ideal goal for this is that we get nice, clean Pareto curves for solving a given task or achieving a level of performance in terms of steps and in terms of compute. That is the goal. There's optimization we can do from there, quite a bit of it, but that is the core simple goal. You switch the view over. Hello, Tim. Welcome. We have a few other things to do as well today. Let's see if we can get started. Go away, Windows. No. Oops. Welcome, Kyoko. This is you can optimize the semi-off-pol stuff. Not exactly. The semi-off-pol stuff currently, Tim, does not work. From the article that I wrote, we have a precise mathematical reason why it doesn't work, and it is unlikely that any of the current methods out there in that entire class are going to work. So what this is instead of doing all those things that aren't going to work, this is something that I can basically guarantee is going to work 20 times better than what we have now. Not 200 times, maybe, but 20 times. We're going to get that. We're going to get that nice and stable. And then if we want to get from there to, 100x maybe, we will reconsider. The article really gives you precise details, though, on everything that I discovered. It's all out there now. Okay, so this is our cart pole, right? Yeah, but it's not necessarily... I guess technically, the only off-policiness that's being introduced here is potentially additional updates. This is not including the replay buffer. That is separate. Holy hell, that is slow. Like literally 30x slower than on GPU. That's funny. Oh, did I mess with the config or something? Why is it? It's solved at 5 mil. Oh, I probably just did 20 mil because it's like instantaneous either way, right? Even though you don't need it. Yeah, so this is kind of the thing, right? You can see the extent to which we just didn't even care about time steps. Like, it's 20 million time steps for cart pull. Puffer's not that bad that it needs 20 million total time steps. It's just that they're basically free, so we don't care, right? No expert data, Tim. This is separate. Welcome, Weston. I think I'm probably going to be in Palo Alto like 2-ish more weeks. We shall see. The goal is to finish my cut here. So as long as I want to do my running training. Just update, everything is fast until you get to masking out illegal actions. Nothing learned if you don't mask and renormalize. In progress. Interesting. And presumably, do you mean that it gets slow in the network side or in the environment side, computing which actions are legal, Jess? Tragic, you're finally awake. Wait, what? Cool, again, pausing. I beg for pausing, resuming sweeps if you're fiddling. Maybe. Well, yeah, maybe. You have to save the state of Gaussian processes, which is annoying. You don't live there? I am seasonally here. Seasonal, Tim. Then a copy pasta. Oh, is it a Zoomer one? Because I don't know that one. This is evaling. Thoughts on using SimD for some M's like Cartpole? Weston, Cartpole is so bloody fast that it doesn't matter if you make it faster. It's already not using any substantial compute time. So you would use SimD not on M's like Cartpole. You would do more advanced optimization on M's where it actually matters. I can appreciate speed for the sake of speed as much as the next guy. But, like, let me solve RL, right? What? What are your thoughts on the Prime Intellect RL environment hub? I mean, it seems cool. They're generally doing cool stuff. I mean, it's not RL environments, right? It's LLM RL environments. It's, like, really, really different from this type of stuff. On the network side, evaluate is way slower than train. How are you normalizing and doing stuff like that? I mean, presumably it's just that the action space is massive, Jess, right? And, like, just having the giant-ass softmax is annoying. I would go look into, like, different ways that chess action space has been parameterized. Like, the flat one is really convenient in some sense. Right? It's, like, a really convenient one, but I don't know if it's, like, reasonable to expect it to be performant or not. More calcs during a single step. From neural and remote. Yes, Weston, but it's not... I could be mistaken here, but I don't think... It's not like a simple optimization to apply like generally to all m's. It is like a specific you'd have to apply specific optimizations to specific portions of each env that you want, right? Most folks are doing the alpha zero approach, which is flat action. Great. Basic. Helps, but not enough. Most folks care about performance. Supervise with value head rather than a policy. Alpha beta search for the value head. There are some works on like doing chess without search, right? I'm trying to think fundamentally what you can do with that stupidly big action space. I mean, you could try like pointer net type thing. Pointer net thing is like you give it like top n actions or whatever. You give it like n actions and it has to pick. I suppose you could do that. I wonder if that makes sense for chess. Does it really just... I guess it makes sense. It just doesn't learn anything if you don't give it, You know, this is something I've been meaning to investigate. Like, in my mind, if this is set up correctly, it should be able to learn to make valid moves quite quickly. Something is going wrong that it's not... Like, right? Because invalid move map, it's a one-step, super easy, no credit assignment, right? I just run multiple M's at once, so technically not faster, just more. Yeah, so Weston, there's a maximum number of M's that you can run productively, and we kind of already do that. And UEs are honestly impressive. Fast training on CPU. 10 to million. 10 to... Wait, what? I do not believe that you have fast 10 to 15 million params on CPU. Like, no way, right? Like, not fast by puffer standards, right? Not by puffer standards, but fast. Well, we should get puffer standards, right, Jess? No, I see this being a real problem. So, I would probably have to run some tests, right? Like, in my mind, you should be able to learn invalid action reduction quickly. I've seen it not really work with Go, though. Well, but then again, you don't necessarily know. I don't think we ever logged, like, invalid move percentage rates. You should probably give it, like a negative penalty for invalid actions, and then also log, like, the fraction of invalid actions being made. See if that's going down correctly or not. I don't know what you mean NNUE. Including sim... Okay, is this, like, some broader thing? You haven't tried SimD? No, Weston, because it's... You can mess with that stuff for sure, but, like, that's going to be applicable to the slower ends more than anything. Honestly, even, like, if you have to do, like, valid action computation, maybe even in chess. CPU compute is still a large bottleneck for me. What M's are you doing that CPU is a bottleneck? Literally, it's not a bottleneck on Neural MMO3. Like, most of the time that CPU is a bottleneck, you're doing something wrong. Most of the time. Okay. To that real quick. Right. Okay, so the plan for this is going to have to be a relatively small set of stuff, honestly. Efficiently updatable neural nets. Color agnosticism. What do you mean color agnosticism? You mean like what side you're playing? That's not typical. Like, that shouldn't be too hard to do either way. It's just flipping the board. Where are you streaming? Where am I streaming from? I'm in Palo Alto at the moment. Old laptop CPU. High physics compute like pendulums. Yeah. So that would make sense, Weston. But if you're on an old laptop, like, then if you're training on CPU, you're going to be bound by that anyways, right? Like, I can optimize this for relatively low end, but I can't optimize this for, like, potato. This is why we have the cluster, right? And, like, repeat contributors can get access to our machines. Because the barrier to entry is very low, but it's not nothing. Read from MPSL. Yeah, that'll help a lot. I mean, like I said, right, we have... Need to show this real quick. We have machines in the back here. You can get access to one of these. You submit some cool stuff to Puffer. I mean, I bought these expressly for that purpose. Yeah, Weston, I've meant to be, like, I've meant to do that at various points. I've just, like, never had to for any specific project. You know? We balance vecnum-env and env-num-envs. That's difficult. Yes. We like the flag. I mean, it's the training facility, right? You have to have a flag in your training facility. Yeah, what's up, Ryan? You doing that hack? I'll take a look at that, Jess. Coming up with next research idea. Million step per second net hack seems like a pretty solid one to me. I mean, the other thing that you can do, right? I like the things that like make sense for you to me are either that or um if you want to actually like make a lot of the real science side stuff in like curriculum and meta learning and like multi-agent and all these different things work, we can actually do it now with Puffer. You would have to write like you'd have to write M's in C to do it, but they would be like super trivial toy M's in C. I could probably do most of these in like a couple hours a piece myself. And it's mostly experiment work after that. I mean, there are multiple different things that you could do, assuming you're not just getting LLM pilled. Welcome, Owain. Definitely wants to do some bigger picture stuff, and I kind of agree. I don't think LLM stuff is bigger picture stuff at the moment. Can I hop on a call? If you don't mind that we're still on the stream, yeah? Uh, Let me fix my... Can you hear me now? Yeah, there we go. Stupid Windows update always breaks everything. How's it going? And let me fix this as well. Say something.
Hello?
Yeah, there. Okay. I got everything fixed now.
All right, perfect.
I found out some cool stuff in the last couple weeks. Put an article out on it. I found the core mathematical reason why all this, like these off-pol and whatever algorithms just suck.
Oh, I think I read that. Yeah,
Yeah.
that was a good article.
Uh, that is actually settled now, which is kind of cool.
That's awesome. So what's next then?
I think I can just literally re-hyperparameter tune everything with our like awesome algorithm, and if I set everything up correctly, we're gonna get like 20x sample efficiency on everything for like less than 10x compute. Like we're
Sick.
not gonna get soda sample F, but we're gonna get like practical real world sample F for basically free.
That's awesome.
hmm And then there's more to do after that, but like this is a damn good start. And like basically, it's just become clear to me that none of this published stuff actually works at all as advertised. Way more
Yeah.
so than before. Like before, it was just like me generally putting together intuition and experience. Now it's I have actual precise reasoning for everything.
Mhm. Well, yeah, that's been my problem because I've been doing a insane amount of literature review this
Mm-hmm.
past week, and I keep seeing papers that do the thing I wanted to do,
Mm-hmm.
and it seems like it works. But then, if the thing they're doing worked, it would have solved so many problems that we haven't solved yet.
Yeah,
So like,
shit
it
doesn't
can't
work.
actually work in general.
It just doesn't. I tried the world model stuff is a total mess. Off-pol's a total mess. Like everything's a mess.
Yeah. So the question I had for you was, I'm looking at a lot of methods that like kind of Go Explore, right?
Mm-hmm.
Kind of takes advantage of the fact that you can
Hmm.
reset the environment.
That's funny that we
So
actually got to that at the same. I was thinking about that as like that would actually work.
yeah, it works, but of course, it only works in simulation, and even the policy based one still relies on you having like a deterministic simulator. So I guess my question was, since a lot of the stuff you're doing depends on the ability
Mm-hmm.
to write your problems as a fast simulator, have you thought about like what kind of problems can and can't be simulated? Like obviously anything with a human interaction is really really hard to simulate,
Mm-hmm.
but I don't have any clear ideas outside of that of like if we have a method that solves any simulation,
Yeah,
what problems can we actually solve?
a lot of them. And honestly, the Go Explore stuff is not even that hard to build into Sims, right? Like you just need to build the sim in a way that it is efficiently state settable, ideally batch state settable, right?
You don't even need to do that. It just has to be deterministic and you save the list of actions to get you to the state you want.
Yeah, but we want it to actually be fast.
If you want it to be fast, that helps,
I
but
think
like
that's
it works
crucial.
even if
I
you could
think
just
that should be
reset.
made at like first class citizen is can you do it in sim fast? And the answer is yes. Like if you just do it smart from the start, the answer is yes.
Well, I just mean the method will still work as long as it's deterministic, and it's not that slow because like RL takes a long time, but just building one trajectory to the point you want to get to isn't that slow. Like you have to take an extra 1,000 steps during your reset. It's not like
Mm,
ideal, but it's not bad.
I have too much respect for like what you get out of efficient M's now to agree with that.
Okay,
Let's say. Like you're right in theory, but the thing is in practice your experiments just take too long and you get nothing done.
okay, but like back to the question: are there
Mhm.
any things that you've thought of that are like, yeah, we would never want to build a sim for that because it just either is too complicated or we would never be able to get it precise enough to transfer, or um,
Hmm.
I don't know. Like, have you thought about like what the limits of doing all this work in simulation is?
Well, I don't even necessarily know how good RL is, like conceptually, in the low
Mm.
data regime at this point. Like we might just be in the wrong fucking field.
Yeah,
Like
I do agree with that.
right? Like I in my mind, I guess this is where the shitty model based stuff comes in, but it's like do you know how much data that they go through in hallucination for like Atari and Dreamer? Like how much
For the like
hallucinated data?
imagination step,
Yeah, do you know how much it is?
I know it's a pretty insane amount.
Do you know roughly?
It's like I mean, they do like 16 imaginary steps per sampled real step, but they have a replay buffer, so those ratios could be
Okay,
different.
I read a number
Um,
somewhere that was 650 billion steps of imagined data for a fucking arcade game.
I could believe that, yeah, because it's
That's what we did for
well,
Neural
actually,
MMO 3.
we know what it is, right? It's 64 replay ratio times 16 imaginary steps, so that's what
You got to be
65
careful
something.
because the way they
Yeah.
define these things. This was the other trick that I found, is they actually the way that replay ratios is defined. It's number of gradient steps per sample. It doesn't take into account the mini batch size.
Oh, okay.
It's really sketch. But basically, yeah, what happened is it turns out there's a difference of like tens of thousands in the amount of compute applied to on-pal versus like wall clock efficient
Yeah.
on-pal. It's like tens
I
of
think
thousands
it's
difference.
yeah. I think they run each data point like or like imagined data point. They probably have
A lot.
1,000 times the amount of imagined data points that you would train an on policy method with. So yeah, it's an obscene amount of
It's an
data.
obscene amount. And yeah, I basically it's not like simple to make work either. It's not like if you sneeze in the general direction of uh world model based stuff that stuff works.
Yeah, exactly.
Like I tried this stuff and I got it to solve Pong eventually, and that was like it.
Yeah.
It's really sketchy. So I
Okay.
think that
And
that's
then
probably what you would have to do um
sure.
if you wanted to go to a really low data regime. It's like a completely sort of different approach, but like that whole area of work is super sketchy. Um
Yeah. So okay, in
and I
that
don't even
case,
think it's
here's like a
good.
slightly more
Yeah.
yeah. I think I agree with you. I think RL just might not be the right paradigm at that level of
Well,
amount of
like
data.
the type of RL we're used to at the very least, right? Like
Yeah.
model free, like engineering heavy, like that type of stuff. It's like, oh, it's scalable, right? But it's like,
Mhm.
yeah, let's just ignore the constant factor of 10,000,
Sure.
right? Which is
So
like not practical in the least for anything.
yeah. Slightly different question. Do you think there's a difference between the simulators that we can write deterministically and those that we don't have a deterministic simulator for? And like one example of that
Fucking
is you
seed
can
it.
well, so sometimes that's true, sometimes it isn't. So like for
Why?
example, you can create a deterministic simulator that mimics Minecraft,
Mm-hmm.
but Minecraft itself, I don't think the dynamics are suitable. I might be wrong about that, but like I don't think you can dynamic like you can't see the skeleton behavior or anything like that. So if you want to train on Minecraft, you have to recreate it from scratch
Well, you have to
to
do
get
that
that kind of
anyways because
behavior.
it's slow as hell.
Sure, that's true. Um, but do you think? Well, I guess it's just a question of how feasible it is to recreate these things in
Very if
like a
they're
close
useful.
enough way.
I mean, here, you and I are used to thinking about like, can we create big, like recreate big game, right, for research? That's not
Yeah.
the actual end goal of this, though, right? It's like recreate big industrial sim to solve incredibly like broadly useful and profitable problem. You can
Yeah.
absolutely, if it's like, yeah, hey, it's gonna take us, it's gonna take us a couple $1 million to rewrite this sim, versus you're gonna go have to buy tens of millions of dollars worth of GPU hours to train this super clunky model that's going to also still be expensive to deploy. Like,
Mhm.
it's a clear cut win, right?
That's true.
So
Okay.
in my mind at least, like fast sim with high data regime RL is really good, and
Mhm.
like slightly slower sim, this is what I'm solving right now, right? We're still going to be able to do that well. It's only when stuff gets really slow that it gets sketch. Yeah, Weston.
Gotcha. Okay. Because yeah, I've been thinking about some stuff in the kind of go explore direction, but that
I think it works.
yeah, yeah,
I was wondering about like doing more of that type of stuff. The only reason I haven't is because, there are industry people with existing sims that they want to like run stuff on existing sims. Um,
yeah.
but I like even like big game companies, right? But I think
Mhm.
eventually that yeah, we're probably gonna want to do that. Um,
Mhm.
I haven't started investing into that stuff just yet because like the current thing I'm doing can already be way much like way better. That might be like after, okay, we have good on PolyRL. This is about as good as it's going to be without making stuff way harder, more complicated, or whatever. Um,
Yeah,
then I think it's like, okay, can we go explore things? And I wouldn't do like can you get like train a policy to get back to X state? Or like, I wouldn't even do that. Just do basically the original formulation, assume we just get fast state sets and crush it from there.
yeah. I mean, if we're in the setting where we're gonna have those anyways, no reason to do the whole
Yeah.
policy-based exploration thing.
And I just Houdini to adjust his question in the chat as well. Not Houdini. Like, what the fuck is a psychic? I don't know. Who's this? Whatever.
No, was it
Ninja'd it.
Nostradamus or something?
I don't freaking know. Ninja'd it. Good enough.
Thoughts on the follow? Oh, Intelligent Go Explorer. Is that
Mm-hmm.
is that what he's talking about?
First return, then explore. I don't think Intelligent Go Explore is the
Oh,
LLM one, or no?
yeah, yeah.
Yeah, the
So first return,
non-LLM
then
one.
explore. Basically, just go explore with the goal condition policy.
Yeah.
Yeah. I'll probably. I'm looking at ideas that are in the ballpark of Go Explore and Intelligent Go Explore. Probably like some middle ground between the two. Because that one,
Mm-hmm.
Intelligent Go Explore was actually just a prompting method, basically,
Mm-hmm.
which is not what I'm interested in, but
Yeah.
something that actually trains an RL agent, but
Do not have
uses
to
Go
rewrite
Explorer.
NetHack.
Um, no, no, NetHack is seedable. Um,
Oh, so it's just gonna be slow as hell, but uh
well, okay, your version of slow as hell is one thing. If there's an LLM with a loop, I think NetHack is actually not going to be the bottleneck.
I wouldn't put an L. My version of this was get million step per second NetHack and just crush everyone.
I do think that that is probably a baseline that I want to build, but there's I got to figure out what's going to make sense. Because honestly, the correct answer is probably don't do the research on NetHack first, like do it on Crafter or something,
That's even
and then
slower.
if it works, I would do it on CraftX probably, like
That's actually
but
still kind of too slow. That's actually slower than NetHack.
I don't think that me rewriting Crafter in C is going to be faster. Like obviously, if I did it, it would be, but that sounds like it'll take a while.
Craft X, I could make 10 to 20x faster in C. Like,
I
it's
could believe
slow
that.
as hell. It's like 100. I think you can maybe get it to 200K, but you're using your whole GPU on that. That's not CPU.
Yeah,
In the
that's
ass.
true.
I don't know. Jack's shit is miserable.
Yeah, I probably wouldn't even want to run it in Jax if I could avoid it, or like it'd be,
Well, you have
obviously
to for
running on.
Craft X.
Well, you could run it on GPU, but then use like CPU based infrastructure. I'm
Oh,
not sure what the I'm
it's
not sure what that would look like though.
I've tried that before. I think it's a little sketch.
Yeah,
Like we just I don't know. I'm so sick of dealing with crap like stupid clever infra. It's just stuff needs to just go to C and be fast and not be stupid.
Yeah. Well, okay. Do you have an environment that is similar to Crafter
In
that
what
has like
sense?
hard exploration problems in it? So
Neural
basically, I'm
MMO
looking for
3?
something that has. Yeah. So what's like the hard exploration task in there?
You have to go fight enemy, pick up tools, like equip tools, go harvest like other things around map, get equipment, equip things, go fight and fight stronger enemy that you can still kill, and repeat
Mhm.
5x to get max level gear and such. And you have log linear learning curves that have baselines up to 600 some odd billion steps.
Okay. I could see a neural Mo 3 thing working.
I mean, that's fast at the very least. If you want like a
Yeah.
relatively tough, and it's the only thing that we haven't just full solved, pretty much in our
Yeah.
toolkit.
I'll consider that one because that would be nice. It
I don't
should
run all my
run faster
experiments
than
on it.
anything else I have.
Did I show you? I did put in the article the crazy curve on Neural MMO with a little sample reuse, right?
I don't remember.
So basically, it takes 5 billion steps to start learning anything on Neural MMO 3. If you
Yeah.
give it a tiny bit of replay data, just high advantage data, even though it's off ball, you learn instantly. Because it's a really, really sparse task from a random policy.
Right.
Because you have to basically stumble into and defeat a level 1 enemy, and it's just really sparse.
Let me find that article so I can see this curve.
I spent some time on it. It was a good article.
Yeah, I think I read most of it. I think I just forgot the curve itself. Where is it?
You do real
Oh, this
research now.
one. This is some serious research.
Like, oh, I'm sorry, do you publish? No, oh no, I'm sorry, I do real research now. Slowly just piss off more and more of academia. You Kaggle. No, I do not, Spirit.
Okay, so honestly, based on this curve, I think this idea I've been floating around would probably
Hmm.
work kind of well in Parallel Mode 3. So I
That's a
might I
kind of
might try that.
crazy curve, right?
That is a crazy curve. The
That's one of the cooler things I
yeah,
found out. And that works with a few different things as well. Like, there are a few different methods that will get you that sort of a curve as well.
right. Okay.
But off-pol in general just sucks. You can't do that. So there's
Yeah,
not like a clean way that I've found so far to put this into on-pol.
right.
It might end
Um
up being something as dumb and simple as just like do a behavioral cloning step every so often and just don't train the value function during that so it doesn't get too stale and like use separate value head. I don't know. Um,
mhm.
but I haven't messed with that enough.
I did find this one paper that was kind of cool. Let me see if I can find it again. It was basically talking about how um behavior cloning, well, it wasn't really focused on behavior cloning. Um it was basically talking about how if you want to like clone from a policy
Hmm.
and use that for transfer learning, so you have like a policy that's good at some stuff but bad at like kind of the start states in a task, then direct behavior cloning or like fine tuning generally doesn't work because the agent will forget how to do all the stuff it knows how to do at the end of the game when it's focusing on like getting through the early game. So not like training. It's not like behavior cloning from an RL agent, but if you imagine like behavior cloning from like an LM or something that knows important things about the game but isn't good at just basic control, then as you fine tune it, it gets good at control and forgets all of its knowledge of the rest of the game. So it was basically
Mm-hmm.
methods of preventing forgetting, but oh, here it is.
So you just mix all your damn data together if you can.
Yeah, they basically showed a bunch of different methods of preventing forgetting, and they test on NetHack and Montezuma's Revenge, which I kind of liked because
Hmm.
those are kind of the exact settings I'd want to see the stuff in. This article, here it is. Also, the author's done some cool stuff on NetHack, so I'm
I've
always a
seen like
fan.
such stupid stuff happen over the last few weeks with my own lit review.
Yeah,
Like, stuff where it's like, oh, it's behavioral cloning instead of RL, yay, but then it turns out to be 2000x sample reuse. like literally, or
I
even
keep
like
seeing these ideas that are like using LMs to suggest actions, and when I test them in like the most basic environments where they're obviously going to be good, and I'm thinking that there's just no point in studying anything like that because they probably just aren't good enough in real RL environments.
yeah, you see why I've gotten myself out of academia. It's like I want to go do real work.
Yeah.
Um, fuck is this? That okay? You don't need an LLM for this shit.
No, no. This isn't LM based. I That was just the example,
Oh,
but
okay.
it's basically just if you have a method that's already good at something and you fine tune it with RL, um, like you have a policy that's behavior cloned up to a certain level and you want to improve it with RL, it'll actually get worse because it
Well, you
forgets how
should
to
mix
do
your
the
bloody
stuff.
data, shouldn't you?
Yeah, this is basically talking about different ways of solving it.
Yeah.
Um,
I
so
would
they evaluate a
just
bunch of stuff.
mix. Well, to be fair, that is actually not that far from what I would do, but I think that you just have to mix your data and you either don't do too many behavioral cloning steps or you have to like kale your value function or something like that.
Yeah, and yeah,
One of
that's
these.
basically what this paper is showing. It's all these evaluations on, and the important thing to me is they evaluated on NetHack, which is
Mhm.
like the hardest setting for that kind of problem.
Mhm. But in my mind this still doesn't solve cuz it's like this is still use expert data, I suppose.
Um,
Behavioral cloning.
so well, no, it's not expert data. It's like decent data. So we don't. There is no expert data for NetHack in the
Hmm.
sense that there's no data on beating the game. Um, there might be like a couple examples in the data set, but for the most part, the data goes to like 20% through the game.
It's still like in my mind you should be able to basically you I'd like a method that just allows you to reuse samples that I
Mhm.
can dump. If I have external data, I can dump data into that buffer. If I don't have data from an
Right.
external source, I can like it could still be highest advantage segments or something, and
Yeah.
then it's effective, like just better prioritize
But
replay. There's
like,
no
if you
method
have
that
a
does this
method,
now.
that's true. But if you had a method that mixed behavior cloning with RL tuning in some capacity, then this would be relevant because it's basically a way to make the RL fine tuning work better on top of your behavior cloning. So, like, even if you're just doing self behavior cloning on high advantage samples, then this is relevant because, you
Yeah,
know, it's a way of making that work better.
I don't know. Maybe that's a good enough thing to do. I guess there isn't like just that and kale the value function. It seems so stupid to me that this is what we're stuck with. That we just
Yeah,
can't use. We just don't have a good way to use off-pol data at all.
it it really is frustrating. I keep looking at methods and I'm realizing that we're all like all these different approaches are stuck in the exact same problem and no one has a solution to it. And I'm
Well,
just
nobody recognized the damn problem. Like, I guarantee you, people are gonna read the article and go, "Oh, yeah, it's so obvious." No, you didn't know that, right? Like,
yep,
that's not at least to that level of detail. No, there's basically no understanding of that anywhere. Fuck, I didn't know. Like, I didn't know until I went and really looked at stuff. Um,
yep.
I it could just be that yeah, the thing of doing behavioral cloning is just what we do. That seems so bad to me because behavioral cloning is not. It's not like a nicely weighted. Do you see the advantage weighted regression paper?
Advantage weight. I don't think so.
Okay, so there's a paper called advantage weighted regression that's just behavioral cloning weighted by an advantage function.
Hmm.
The skeleton in the closet there, right, is that they use a utterly stupid amount of resampling.
Okay.
So it's like, in my mind, if anything, this should improve sample efficiency, right?
Hmm.
I mean, not even, it should improve its sample efficiency and wall clock, both.
Right.
Like, because you should be spending less time on stupid samples that don't tell you anything, and just a couple more updates on samples that actually do tell you something. We can't do that now.
Yeah.
And if you can get this to work, you also solve the forgetting problem, right? You can just keep around data from different chunks of this. Like you can just keep around different chunks of good data from different parts of the
Yeah.
trajectories.
Yeah.
But like you basically can solve everything if we just solve this one stupid thing. But I spent 3 weeks on it and I don't know.
Mhm.
I know what doesn't work. I have a very, very good understanding of what doesn't work. And I at least know I can get us a 20x sample of efficiency for basically free.
Okay.
Mm. But
I
look at
feel
these
like
plots. This is 1E7, 1E8. Who has any data?
I'm mostly looking at methods that can like still dealing with the exploration problem because I feel like since I was working on curriculum learning for a while, a big problem with it is just that even if you have a good set of tasks, it takes agents so long to just randomly discover the behavior they need to solve one of the small tasks that like curriculum learning works worse because exploration's so hard. But if we could make exploration better, then some of the curriculum learning like just skyrockets your performance because you're just
There,
solving tasks left and right.
I mean, it's usually the case that a lot of these older bits of research, even if they were completely wrong on 90% of stuff, there's usually like a little glimmer of something in there.
Yeah,
These surprisal based things and like world model, like there's something to this stuff. It just hasn't been done in a reasonable way. Um,
yeah,
like agents, RL agents don't like try shit out when they're stuck. Like
right.
I've never seen that, right? And it's like a
Yeah,
very like once you get to a certain level of intelligence, like the minimal expectation is you just start trying shit out when you're stuck, right?
yeah.
And it's just never happened.
Yeah, I mean that's why Go Explore was good in those deterministic environments because like you use your good policy for a while and then you do random stuff once you're at a new state, which makes sense. And then intelligent Go Explore also makes sense. You use an LM to choose your random actions, so it's like slightly more common sense based.
Welcome, Drover.
But there's still no approach that does that really effectively for hard exploration RL environments in like somewhat more stochastic settings.
Yeah.
So I'm kind of looking at those. I'm trying to see if I can come up with a method that could theoretically solve that hack. I'll probably won't test on that hack first because it's such a
If you
insane
just
amount of
made the
work to get
damn
those
thing
baselines going.
fast, it would be a lot easier on you.
Yeah, but like that level of like that's a lot of work. Like I can run like we can run the stuff even if we run it fast. Like recreating the baseline is such a huge amount of work.
Hmm.
And I'll probably bite the bullet and do it at some point, but I don't know if I want to do it as the first step to
That's
testing
fair.
something. Like I think I want to get results fast.
Yeah, that's fair.
But I also will probably I will try my best to insist that we put out results on that hack if
I
I
mean,
write
if
this
you
paper
want
because
fast M's,
that's
you
my goal.
really like the much easier thing to learn to just do quickly is you should just learn to hack together some probe M's and see. It's really not that hard. It's like a few hundred
Yeah,
lines of code. You can do it in a few hours once you have the basics down, and it'll just be like really helpful for the next couple of years for you.
that might be true.
It's really
I mean,
not
I think
hard. Like if you just look at some of the code, it's not hard.
yeah, I do think neural MMO3 would be a very good starting point on its own though.
Yeah, that's obviously the bigger one. That's not like a few hour project to make that env, but I mean, I have
Yeah,
built simpler envs. Like, and there was literally one time for a client where I I had them ask me a thing about memory. I sat down, I wrote a probe env, I ran 16 experiments, and wrote up a small report in like 3 hours.
yeah, that's nice.
Yeah, yeah, Drover. This is going to be based on hyperparam tuning stuff that we're going to be doing here. How are things otherwise? Have you decided to start my ludicrous training regime?
I don't think I know all the details of it, but the answer is definitely no. I have been exercising though, so that's
Wait
good.
until you see the results of this thing. Yeah, you don't play League, otherwise I
Terrifying.
could give you a reference point.
I know a little bit about League, but I definitely don't play it.
Have you seen the profile characters of that, like the profile pictures of from that game, like the artwork for the
Some of them, yeah.
characters? That game is
Yeah.
hilarious because half of the characters are just random chibis and the other half are just like very sexy
Yeah.
people.
Yeah.
So yeah, think like, I don't know, like Kane or Tryndamere or one of those. That's the physique goal, yeah.
Hell yeah. Yeah, I'm not getting there. I'm trying to get to like run 2 miles without dying.
It does get easier. My suggestion is for running, you just like suck it up and you do it 6 days a week. And you
Yeah,
stretch.
that's
You
kind
do
of where
stretch
I'm
a
going.
bit. Um, yeah, you stretch a bit. If stuff feels like it's wrong, not just sore, but like wrong, you take a break before you hurt yourself. But I did that, and this is now I finished the first month of this training block,
Mhm.
and I went from like 6 miles being hard and like hour 12, hour 15 to I got a PR 53 minutes for this 10K on a hard course. Like down was that 20 more than 20 minutes, right? Yeah, like 20
Nice.
minutes. Um and like I did, a 16 miler, I did a couple half marathons in the course of a month. So you can build it very, very quickly, but it's gonna suck for a few weeks. That's basically it.
Yeah.
Put on an audiobook, zone out, just run.
Yeah,
There it
I think
goes.
that's the plan. I mean, I've been doing good so far. See if I can keep it up.
It is very much worth it. It's the most worthwhile thing I do, but it
Mhm.
does suck. It does
Yeah.
suck. It doesn't stop sucking, but you get able to deal with it better.
Yeah.
That and the deadlifts 5 times a week.
We'll work our way to that.
Yeah.
Um, yeah, honestly, I'm pretty excited about the postdoc in general. Everyone in the lab is super cool,
That's fun.
doing cool research. I'm excited.
Yeah, well, hopefully I can run some support for this stuff. Um,
Yeah, I think we'll be talking much more once I have an idea off the ground because
yeah.
I would like to be able to run things in PufferLib if I can.
Just take a quick look at the snake code or whatever. Have I shown you that before?
Yeah, I've seen it.
Just like go read that and then just you'll see that it's like, oh, okay, I can do this.
Yeah. No, honestly, neural MMO seems like the best fit, so I think that's a good starting
Yeah.
point.
Grover, this is the RL training regime. It's just the RL applied to the researcher instead of to the researcher's agents.
Both important.
All right.
All right. Yeah, I'm gonna get back to reading copious amount of papers and putting something together that I can actually work on.
I'm gonna go back to fixing this ridiculous field.
Please do.
Yep. We'll be done. All right. See ya.
All right. See ya.
Always fun chatting with Ryan. Ole, welcome to all the folks on YouTube. Every time I end up like shooting the shit with one of my researcher buds, everybody's very interested all of a sudden. For folks new around here, I'm Joseph. I do RL research. I stream all of my research. I build PufferLib. PufferLib is open source, extremely, extremely fast reinforcement learning. You can get involved and start training agents on your laptop in seconds. Many of our contributors came in with no RL experience and built things like this, which you can now see on our website. So yeah, there you go. Okay. Um, the goal that I was thinking about before that call was how we are going to adjust PufferLib to automatically run a ton of experiments that not only see how fast we can train agents, but also how few samples we can, and to balance both of those goals cleanly. Welcome. So I know this one's pretty easy. I can set one hidden size parameter. I have these two different num-envs parameters. I can just fix the number of cores to some number, right? I think I can. Yeah, if I just fix vec num-envs and only tune env num-envs, I think that'll be fine. Just got to my remote place in Spain. I'm going to lock in for the next 10 days. That is excellent. That's honestly precisely what I recommend is stay off social media, do a ton of exercise, focus on work for good chunks of time. Mostly how I work, frankly. Today is kind of an experimental day to see if I feel refreshed enough to really start the next block of work or not yet. I did a pretty heavy block for 3 weeks while I was doing all of the research on off-pol and world models and stuff. And I'm also in the last couple weeks of a very brutal cut. So I'm not necessarily hungry, but I am fatigued. Very much fatigued. So we're going to see if I can make progress on this or not. If I can't, I will go do other things for the next week. If I can, then we will start on this. Vecnum M's. Yeah, everybody hates that distinction. I should probably change Vecnum M's to like Vecnum workers. But the thing is, it's the total number of environments is Vecnum M's times Envnum M's. And I probably need to change the names at some point. I feel myself getting a bit scrolly. Yeah, so the problem with X Drover is it's a necessary evil, right? X is like a very necessary evil. I would be a much happier person, I think, if I just completely deleted it. But the thing is, this is the entire source of like reach for Puffer and most of our inbound stuff for clients and a lot of other stuff, right? So in my mind, this replaces advertising for all of my work. Now, I wish that the app I use for that also didn't have this stupid addictive scrolling component. But here we go. Here we are, right? Any good PhD application advice? Go try to find and talk to the professors you're interested in working with. They will not reply to you. Their students will. Actually know what the hell that they do and make sure you're actually interested. PhD is an investment of 5 to 6 years of your life. Do not make it lightly. Yeah, exactly, Owain. I don't know why they decided, oh yeah, the everything app thing. Like, I don't want a freaking everything app, right? I mean, I like having this stream. This is chill, right? But I want to just be like left in peace to, stay fit, work on research to solve actually important problems, not like the performative pretending to solve problems, like actually solve problems, and then get sufficient rest to stay sharp doing all of that. That's basically it. Searching RL on YouTube, yeah. So, I mean, now you see why I have to do a little bit of the promo, right? Because otherwise people like you don't find this. Like where academia was in theoretical physics. Yeah, academia and RL is a total mess as well. I know maybe I'm jaded. I had a great advisor and everything, but like academia just is not. It's really not the place for new ideas, right? It's only the place for certain types of new ideas. You don't need a new operating system. There's really not that much you would do different. Exactly, just Linux. And you could try to like actually make Ubuntu properly stable and like stick a better desktop env on it or like add some customization, but and that would be nice, but that's basically it. Like I would love a version of my old try-hard i3 setup from undergrad that like actually works and doesn't crash everything constantly. I did Pong with PufferLib, got to work on shitty PC, use it on fiber optic network graph, and get paid on the clock for practicing PufferLib. Awesome. That's awesome. If you are part of a larger company that is interested, we do have we do contracts in a specific area. I don't know if it would be large enough to make sense, but there is stuff we can do. If not, you're also free to just do it yourself. It is all open source. And I'm generally happy to just see people solving cool problems with my stuff. Yeah, I know what to do with this now. I've sort of thought through it. Okay. So here's what we're going to do. This is going to have to be... This is going to be Argus policy for now. Unironically, if we manage to get that chess M solid, we could name Puffer Chess and register it to the Computer Chess Championship. That'd be fun. It's very difficult to beat the dedicated stuff, Jess, because like, search versus not search is tough. And also like chess is a area where there's just been so much domain specific work. But I mean, if we could get a good chess agent that just like runs super fast and doesn't use search, and just as like Puffer standard RL, you train it at home, that would be awesome. Plus, I can't do scale 0, right? Like this. We have quite a bit of funding. Reach out for a 5-minute conversation. Sure. I mean, it really just depends what you're looking into. Okay, solid. This still works. That's better. Okay, so there's several things that need to be tweaked here. Is there a locally hosted I don't really think will work, but worth a scope at least. Sure. And a buddy of mine who's actively in the field. Your article on protein reaction was damn, that's wild. Yeah, it's cool stuff, right? And honestly, like, protein still has a couple quirks to it that I need to fix. It could be way better. Probably one of the things I'm going to do as part of this. RL just has to work. Across the board, no questions asked. Just work. Does anybody know, actually, if I wanted to add, is it just TensorBoard? Radio dashboard? Is this a thing? Or it's freaking sass? Whey protein? I could make the next generation of it creatine. Why did all these freaking things have the shittiest sites ever? Is this not just a tensor board hack? Wait, this is totally a tensor board hack, isn't it? Or did they like rebuild it? Maybe we just don't need to have... Well, maybe we don't need all this crap, right? We don't need like this stuff. Can we just get like a single plot? Yeah, we can just hack something together for this, I'm sure. Okay. That is... Why the hell does it do that? Oh, I see. Didn't add it here. Gonna get a good night's sleep so I can puff up tomorrow. Catch you later. See you around. Why is this suddenly super freaking slow? That's weird, right? Oh. You know, that's actually fine. It's because the sweep args. That's fine. Seven. Doesn't need 2e8, right? You can get 2e7 maybe. Mean is 8. 80, that's crazy. This. That's better. 30 seconds. Hey, Weston. We trained our AI to say I don't know rather than make stuff up. I'll believe it when I see it. Quick question. CPO can handle tons of inputs. Would making one extra input that is technically redundant because the neural... Wait, would making one extra input that is technically redundant because the neural net could learn to infer this value still be a good idea because it would speed... Why would that speed up training time? Why would giving it, like, some random extra crap speed up training time? It would have to learn addition to infer the value. No, it would have to learn to do Wait, what? It would have to learn addition to infer. No, it doesn't. It just has to learn to zero the weight on the input. Not how that works. Learn to zero the weight. Or to learn some combination that zeros the weight all the time. Not the same thing. No, just giving it noise is not going to help. Took a break on the walker and kinematics. We're giving me a headache. Working on agent controlling a boat. Dim fluid dynamics. What? Heck of a break there. Well, yeah, because its entropy is... I actually don't know what the heck that is, frankly. I mean, it's a bad run, clearly. What I want to do about this. There's so much that can be fixed here. Optimize steps, optimize time. Just a basic Navier-Stokes dynamics. Hardly frickin' basic. Okay, so there's this mini batch problem. And then there's the BPT horizon problem, right? Annoying. Yes, this is like a totally different regime, right? Hmm. Well, let me think how we design around this. Is there a good way to design around this? Annoying. You're definitely gonna do sweep. Well, shit. Why I didn't do this before, right? Massively screw this up if you do it this way. Yeah, there's quite a bit of redesigning of rethinking of things I have to do. I think I just need to mentally readjust to like, instead of this is an easy problem I can solve quickly, to like, okay, this is a trickier problem I will solve more slowly. Do we not have, we do. Still not good enough, though. I don't like this being in every file. I don't like passing quargs like this shit either. Basically, like, when you try to cover a larger regime of different stuff, a lot of combinations of params are invalid, and a lot of the methods typically used for this kind of punt. Classical physics is pretty much all I enjoyed at uni. Literally anything can be written as an equation. Anything can be modeled as an equation. What's the ideal fix to this? Equation for puffer tender? Oh, just don't be a dumbass, I suppose. I would like to have this fix. I'm trying to think now, do I want to have... Where are the places I can handle this? Have the trainer handle invalid configs. You have the trainer handle invalid configs. But not dumb, we know I talk a lot. Well, that's funny, because I'm dumb, not stupid most of the time. I don't know, it's kind of like ludicrous to me. I have multiple different XDM chats with well-known researchers who are just like gooning half the time. It's ridiculous. No, what's sad is that I knew multiple people at MIT who had AI boyfriends and girlfriends, and literally, yes, it was both. Yeah, that's like one of the two things I refuse to work on with RL. Don't know how I want to do this. In my mind, PufferLib needs to get simpler than it is now, right? Not more complicated. And like this shit drives me insane. Learning is quite hard when you do not have a good teacher. Learning to teach yourself stuff is not that hard. It's very, very difficult to teach yourself stuff efficiently, though. Like the way that this is. If I'm clever, I could reparameterize this such that invalid states are impossible, at the price of substantially obscuring. The price would be substantially obscuring what's going on, which I don't like. Yeah, Jess, it's tough here. Knowledge, discipline, and wisdom. Honestly, Jess, the thing that I have the hardest time with is that I can work very hard, but I can't work very hard consistently, right? My mind gets burnt out for a few weeks, and I need to take a break. And I know it's not a lack of discipline, because in other areas of my life, I'm very disciplined, right? The last month has been wake up, run a 10K on a hard course, do the same hard set of lifts, and then have a very strictly regimented diet on a over 1,000 calorie per day cut. If I could work at peak 100% of the time, things would be done much faster. Discipline can be learned. Go get yourself in very, very good physical shape. It's the simplest. In another couple weeks, I'll probably be leaner than I've been since undergrad while carrying 40 pounds more muscle than then. At least. It's not really internal motivation, Jess, because it's like once I've had a nice break, I come back, I'll look at the exact same problem, and I'll be very happy to work on it. It feels very, very similar in some sense to when you're just burnt from a long training block. But even when you're burnt from a long training block, you can put in a decent enough session. Mental is way harder. When you're doing hard, it's kind of like trying to do either a fast run when you're burnt or a heavy lifting session when you're burnt. It just doesn't work. And there's not really I mean, I can chill here and work at half efficiency or whatever on simpler things. But that's about it. This is kind of fine for a bit. I do want to figure this out. How many of these parameters would we need to screw with to make invalid states unrepresentable? Let's say that we had total agents or whatever as a parameter. Total M's, total agents, some bullshit like that, right? Do you feel antsy when facing the problem or tired? Just tired. Just gears refuse to spin. Okay, so realistically, we could have a total agents or whatever. We could have a total agents parameter. That would solve this one. We let BPT Horizon be whatever it will. I don't want to have to do like num mini batches or something though. Hmm. You can feel free to message me stuff, Jess. It feels kind of normal in some sense to me. Like it feels almost like a direct analog to to like hard physical training in some sense. Yes, and I do all of those, right? $15 a week. The kid. Yeah, that's rough. Eating the dopamine. Hmm. How much training am I doing per week? It's about 15. Probably about 15 as well. About 2 hours a day. Average. I don't like any of the solutions I'm coming up with for this here. It's basically right, like I can reparameterize this in a way that like it's impossible to come up with an invalid config, but then you obscure what you're actually doing. That seems very bad to me. I also don't like though the alternative, right, is that you specify the parameters that you would like to have specified, and then you have to compute a bunch of intermediates and make sure that all of those computations come out valid. That's a lot of additional checking code. You have to basically handle what happens when you give it an invalid config as well, and then when you're sweeping stuff, right, you have to handle it automatically. I don't like that one bit. Not at all. I mean, the vast majority of these parameters don't have this issue. It's really just stuff around the number of environments and the batch size and the mini batch size and all that. It's like 4 total parameters. Yeah, but just the way that PufferLib has gotten to where it is by me spending a lot of time caring about stuff like this. Some details. You definitely don't want to have runs not be reproducible across different systems. The only thing that we do that for at the moment is limiting the total number of cores you use. But this does not handle it. It's not just system details. There's BPT horizon, and then the number of M's. I mean, realistically, quite a bit of different stuff we could do out of this. If I have you sweep the number of agents, fucking compute that. I hate having to compute these intermediaries. The alternative is I could soften it so that you can parameterize a lot of stuff, some of which just might be obviously stupid. Not bad. That could work. I like the idea of explicitly parameterizing as much as possible. We can mess with some things off of this, right? can do it this way. This is good. Giving a hint for the config. I'm trying to make it just so that you can just run sweep and it'll find you your good config for your new env. Out of the box. For whatever it is you're trying to do. We're going to do this. I'm going to do sweep env num ems. Going to be a minimum of one env. Max of 4096. 48. This. Something like this. Better. This results in jank mood? What do you mean? Not bad so far. I'm GUI wrapped PufferLib. You have Raylib GUIs for the ends. If you need a GUI to do RL, you shouldn't be doing RL. BF clip? What? Oh. Yeah, I have to figure this thing out. There's like this weird phenomenon. You know, instead of running this as sweep, let me run train. Or we preserve this. Okay. Wrap puffer and GUI for people scared. If you're scared of CLI, I don't know what you're doing. Hey, Spencer. Yeah, I guess if I wait until... I'm trying to think what's the best way to do this. If I stop now... It's only going to be like 4 by the time we're done at the latest. I guess I can just take a quick break from stream and chat, and then I'll boot it back up after. Alright, guys, I'm going to go chat with Spencer for a bit about a thing. And Yeah, I'm gonna go chat with Spencer about a thing. I'll be back in, I don't know, however long we end up chatting for. For folks who are new around here, this is all research done in public. Everything's at puffer.ai. It's all open source. Start the repo. Helps me out a ton. Join the Discord.